Good afternoon, teachers. Good afternoon, grade 12 learners. My name is Mohapi. I'm going to take you through some few exercises on Euclidean geometry to try and prepare thoroughly for this topic. Remember, this is the topic that takes about 50 marks in paper 2. And remember, paper 2 will be written on the 3rd of November. On the 3rd of November, grade 12 learners will be sitting for their final examination on paper 2, mathematics paper 2. Thank you. Without any waste of time, let me take you through some few exercises just to make sure that I refresh your mind on the application of all the geometric theorems. We've done lots and lots of theorems. I think now what we need to do is just to put them into practice, because I believe once you practice them all, then everything will become easy, and you as learners will also be familiar with the theorems. Let me take you through the first exercise. Thank you. If you can check in there, we've got the question. Let's analyze the question. From my previous presentations, I've always been emphasizing the importance of analyzing the given statement. Once you analyze the given statement, whatever information that you pick up, you immediately indicate that information on the diagram. That is the accompanying diagram. Thank you. Let's go. In the diagram alongside, AB is a chord. You look for AB. Here is AB. AB is a chord of a circle with center O, meaning that O is the center of the circle. ON is perpendicular to AB. Look at ON. ON perpendicular to AB at M. I think we can all see that, and that angle is already marked 90 degrees. MN is 30 millimeters. We go to MN. Check MN. This MN is 30 millimeters. Immediately, you mark it on the diagram to know that MN is 30 millimeters. And the radius of the circle is 150 millimeters. What is the radius? A line from the center to the circumference. Here is the radius. OA is the radius. OB is also the radius. ON is also the radius. So radius is 150 millimeters. This radius is 150 millimeters. All the information that you have, you immediately mark it on the diagram. The question states, calculate with reasons the length of AB. The length of AB. Thank you. Let's analyze. Remember what is given. Radius is 150 millimeters. Check. OA is 150. ON is 150. Look at ON. ON is equals to 150 millimeters because ON is the radius. But if we can check, ON is divided into two. ON is divided into OM plus MN. They must give us 150. Check. OM plus MN, they should give us 150. So we can work out the length of OM. Therefore, it means OM plus MN, check MN, is given as 30 millimeters, which is equal to 150 millimeters. Therefore, OM will then be equal to 150 minus 30, which will give us 120 millimeters. That is the length of OM. So we come here, this one is 100 OM. What is OM? OM is 120 millimeters. That's OM. So let's go through the questions. The question is, we've calculated with reasons the length of AB. The length of AB. Now that we've got OM as 120, it's easy for us to calculate AM. According to Pythagoras' theorem, OA squared is equals to OA squared is equals to OM squared plus MAM squared. This is according to Pythagoras' theorem. Pythagoras' theorem. Now let's substitute. OA, look at OO, it's 150. You square it. OM is 120. You square it. AM is our unknown. We want to determine the length of AM. So let's square 150 with the aid of a calculator. Work it out. 150, you square it. I think 150 squared will give you 22,500. 22,500, which is equal to 120. Let's check 120. What is, how do you square it? What will be the value? 120, when you square it, you've got 14,400. This one gives us 14,400 plus AM squared. Now it becomes easy for us to determine the length of AM squared. We group the like terms. You transpose 14,400, you transpose to the left. Then you've got 22,500 minus 14,400. Let's subtract 22,500 minus 14,400. Let's check the difference. 8,100. The difference here is 8,100. Now we can determine the length of AM by determining the square root on both sides. Therefore, AM, you determine the positive root of 81, even the positive root of AM squared. Therefore, AM will then be equal to square root 81,000, 8,100, which gives you 90. Therefore, it means AM. Let's go back to the diagram. AM is equal to 90 millimeters. That is the length of AM. Therefore, let me write it nicely. AM is equals to 90 millimeters. Let's check the diagram. We've got AM. This AM is equals to 90 millimeters. The question wants us to calculate the length of AB. Check AB. But we know from one of the theorems that we did that AM is equal to MB. Let's write it down. But AM is equals to MB. It's a geometry. We must provide a reason for that statement. Why do we say AM is equals to MB? The reason is, remember, the perpendicular drawn from the center to the chord bisect the chord. Perpendicular drawn from the center to the chord bisect the chord. And the word bisect means to cut into two equal parts. Therefore, we've got perpendicular drawn from center to chord. The perpendicular drawn from center to chord bisect the chord. What does that mean? It therefore means MB is also equals to 90 millimeters. Here, let me go to the diagram. I mark it. Remember, AM is equals to MB. This side is equals to that one. If AM is 90 millimeters, it means MB is also equals to 90 millimeters. Therefore, it's easy for us to answer the question. What will be the length of AB? 90 plus 90, which will give us 180 millimeters. Therefore, you conclude by saying, therefore, AB is equals to 180 millimeters. When you add the two, 90 millimeters. Thank you. It was just a brain teaser. It was just a brain teaser to say, let's start first by working on this one. And my approach today, mainly, is not going to solve the problems for you. For you to understand the solution to a problem, firstly, you need to attempt it on your own. Try to identify where you've got problems. And then thereafter, I'll come up with the explanation, the solution. Then you can check your work out against mine. Because sometimes it does not help to every time come up with a problem and solve it for you. Learners must be able to solve, and for them to realize their weaknesses is for them to work out the solutions. So I'm going to give you a solution, a problem to do on your own, and then after 5 minutes, I will then present the solution. But firstly, I want you to try this one on your